city sidewalks, da-da-da-da. It's Christmas time. Whoa, the light. What are we doing here? Let's get back over to the computer. Okay, let's walk over here to the computer. See what we got coming up on the screen. Oh, what do we got there? Yeah, just some odds and ends. E equals MC squared, unity theory, precession, da-da-da. City sidewalks, da-da-da-da, do-do-do-do-do-do. Working on my patents here. Oh, well, what the hell. Do-do-do-da-da-da-da. Just kind of a little picture there of what we're doing here. Do-do-do-do-do-do-da-da-da. Okay, going to talk about, of course, in the number of things we're going to talk about, what we want to talk about today, or this morning, because it's like 6:30 in the morning. We're going to talk about spin. If you're going to talk about motion and you're going to define or go for the definition of the laws of motion, and we have, two of those laws, both of them given to us observations. We give Newton full credit for vocalizing and putting these things into words. We have the first two laws of motion. One is motion, that everything is in motion, and we don't really define that, but we're going to get to it. And then the next one is every time something in motion hits something, you have an equal event going on, which means you never lose motion, which is basically the definition for why we have change, or why the universe is doing what it's doing, and mass is doing what it's doing, is that you can't lose motion. It's like being in a boat out in the on a pond. Although it looks like you're not doing anything, the minute you try to move, you put motion into the boat, and it rocks and all this stuff, and you see waves. So there's no way out of it. Motion is the event. This is the one thing we're trying to explain, and it basically goes on infinitum, that you can't stop it. The only thing that's happening with motion is changing. So we're trying to figure out what that change is all about. Okay, and what that change would be about, of course, is spin. Spin will give us our next definition, and probably will give us our third law of motion, of course, because it's the only other thing we can basically discuss once we discuss that mass, what we would consider mass, is in motion, and that if it hits another piece of mass, you have more motion. And what we're going to say is that neither one of them give up motion. It just changes, and that is change. So how would we go about defining spin, what spin would be, or how we'd visualize spin, when we haven't really actually defined motion too well? Or reaction. Now Newton, of course, was very capable of explaining reaction, because then he jumped into, giving us a lot of math, which was very good, because it quantitated these quality events, the quality event being motion, and then reaction. And then he jumps right on in with what we call the third laws of motion, which, all this thing about how you measure those events. Okay, he didn't give us a third law, although a lot of people who love to study math and everything like to, they're very good learners, so they jump right on in there. Somebody said he gave us a third law. They learned he gave us a third law and never looked back. But he didn't give us a third law. That's, you could say it's under discussion, but it didn't. He didn't give us a third law. If he gave us a third law of motion, we would have already figured this whole event out, and we haven't. So if you want to maintain that he gave us a third law, then that means you don't want to understand the third law of motion, and you just want to glaze over it and go about your merry way, and that's good. That's all right, because I could be wrong. I'm not, because if you're scientific, you would come to that conclusion. Okay, so we're trying to define the third law of motion, and of course it'll be in spin. And now before we need to go too much further, and although we have a pretty good grasp of what this spinning thing is all about, and we can even quantify it, these qualitative events, we need to really come back and define spin. And basically, when we look at spin, what we're trying to figure out is that the first things we come up with is inertia. Newton came up with inertia. He explained this inertia thing. And we see right away that in inertia is a good definition for motion that's not like most of the motion we see and we call motion. Things moving from right to left, up or down, to us or away from us. These are things that we consider not motion, that as we sit in a chair or we contemplate the world here, we think things are not in motion, but they really are in motion. And this event we can easily call or refer to as the other kind of motion. And the only thing we can come up with is that inertia is motion. So therefore, Newton, that's why Newton didn't give us a third law of motion, because he considered inertia like a starting point. Math has to have a starting point, because we like to count from 0 on up, and then we start again, 0 on up, and then we start again. But in a universe of math, or the physical world we live in, there is no 0 in motion. Motion is motion. It's just redefined. So we need to redefine motion. And one of the things we're going to do is redefine inertia. And I know this kind of roundabout stuff, and maybe can be frustrating, very frustrating. But that's what science is frustration. It's fighting against this bag we've pulled over us that's comfortable, but that's not the world we live in. Now, and the only argument I can give you to this is that none of us, no one, no pundits right now on this universe that are what we call human have this secret. And we'll probably figure it out, fight it out here pretty soon, but the very first step into figuring it out is to start defining what we've got, understand what we don't know, and accept it. And let the chips fall where they may. Okay, well, I know this isn't as good a discussion as we should have, and I don't have all the definitions, and I don't have it all codified and laid out to learn, because this is not a learning experience. This is an exploring experience. That's about all I got right now. We'll go on to something later. We'll get back into, we're going to get in, and I'm going to work harder on this precession or spin is the third law of motion. And we might even get away from the precession, because really the third law of motion is the definition for spin. And from there, then we can, in a Newtonian way, jump into all of this other stuff, okay? Merry Christmas. Christmas to Christmas. Yeah. I think I made one of these last Christmas, and this is the second Christmas. Good way to measure these. Thank you.